These are the solutions for part 7 of the topic 2 and 3 test review. So what I'm going to do is write the name of the theorems down here where the descriptions are. That way it's less to write. Okay, so the first one, the description is mid-segments of triangles are parallel to and half the length of the remaining side. That is called the triangle mid-segment theorem. The next one is, if two parallel lines are intersected by a transversal line, then consecutive interior angles are supplementary. So this one's making the assumptions that the lines are parallel. So this is just the consecutive interior angles theorem. Let's find its converse. The converse would assume that the consecutive interior angles are supplementary and then conclude that the lines must be parallel. So let's find that one. So all the way down here, if consecutive interior angles are supplementary, then the two lines must be parallel. This is the converse of the consecutive interior angles theorem. Okay, let's go back up. If two parallel lines are intersected by a transversal line, then alternate interior angles are congruent. This is the alternate interior angles theorem. Let's find its converse. The converse would be backwards. So it would assume that alternate interior angles are congruent. Okay, so that's this one right here. If alternate interior angles are congruent, then the two lines are parallel. So this is the converse of the alternate interior angles theorem. Okay, let's go back up. If alternate exterior angles are congruent, then the two lines are parallel. So this is the alternate exterior angles theorem. Let's find its converse. I don't even see it right here. Well, let's just keep going then. So it says if point A is on the perpendicular bisector of the line segment BC, then A is equidistant to B and to C. This is the perpendicular bisector theorem. Perpendicular bisector theorem. Next one, if A is equidistant to the endpoints of a line segment BC, then A lies on the perpendicular bisector of the line segment BC. This is the converse of the perpendicular bisector theorem. Okay, next, if two parallel lines are intersected by a transversal line, then corresponding angles are congruent. This is the corresponding angles postulate. Corresponding angles postulate. So remember what the difference was with a postulate, like between a postulate and a theorem. A postulate was just something you assume to be true. Like we don't even dare try to prove it. We don't have a proof for that, at least in this class. Okay. And it's from this one that we can actually prove things like the alternate interior angles theorem and the alternate exterior angles theorem. But we did have to assume this one to be true. Okay. The next one, the sum of the smaller sides of a triangle must be longer than the longest side. Okay, that is the triangle inequality theorem. This one down here, if two parallel lines are intersected by a transversal line, then alternate exterior angles are congruent. Oh, that's what happened. I messed this one up at the top. So this one's actually the converse. Whoops. So this is the converse of the alternate exterior angles theorem. And then this one down here that I was reading, this one is actually the regular. Assume they're parallel, and then that means that the alternate exterior angles are congruent. So this one down here is the alternate exterior angles theorem. Okay, we already did that second to last one. Now the last one, if corresponding angles are congruent, then the two lines are parallel. That's the converse of the corresponding angles postulate. Okay, that's it for question 1. Question 2, I think we can fit it right here. Okay, so I'm going to write the name next to the pictures. So the fact that the three angles in a triangle add up to 180, that is the triangle sum theorem. In this picture, the second one, the fact that DE is half of AB and that it's parallel to it, that is the triangle mid-segment theorem. This third picture is depicting the perpendicular bisector theorem. That's because C right here is the same distance away from both endpoints of the line segment. So therefore it has to be in the perpendicular bisector of the line segment AB. Okay, this one is the vertical, this one is depicting the vertical angles theorem. And then this last one is depicting the triangle inequality theorem. And that's it. Okay, so that's it for part 7. Part 6 happened to be the same thing as part 7.